This recording is for Primary Math 6. We're working the challenging word problems on page 4 through 7. It is my assumption that you're going to look at the sample problems with your student, go through them, work through them, read it, understand where things come from, where the numbers come from, but I don't do a solution recording for those because they are all worked out and shown how to do them step by step. On these challenging word problems recording, it is exactly that, a solutions recording. So I'm just going to work each one, starting with the first one in each assignment and work all the way through it on a recording. And so if you get stuck on any of the problems during the week, you can click on the link for this recording, fast forward to the number that you are having problems with, and watch only that one. Or if you are just having trouble figuring out how to explain something to your student, you could just turn it on and let it kind of roll in the background and kind of understand how I say things, how I do things. Even if you can solve the problems, sometimes you say, I can get an answer, but it's awfully hard and I can't really explain it. This will help you to explain it. So, as I said in the other recordings, the very first topic off the bat is algebra. It feels a little bit hard because it's brand new to the kids, and so hopefully some of the things that we're doing here will help a little bit to make it feel more just something they can handle and grasp and all that. Number one, it tells us that x is a number, and they want us to write down an expression for a number that is 3 more than x. Well, we've done that for a long time. We've just used numbers. 3 more than x means x plus 3. If your student is having any trouble, the way that I would suggest you help them get through it is to make it very concrete. So, for example, let's say the number is 5. What is 3 more than 5? Well, it is 5 plus 3, which of course is 8. 8 is 3 more than 5. And so if x is 5, we add 3. If we don't know what x is, we just use x and make it x plus 3. And of course we can't solve that. I don't know what x plus 3 is unless I know what x is. So leaving it as this kind of an answer is sometimes the hard part. They don't understand that, yes, that can be the answer. That's all we're looking for. Part B, 2 less than x, same thing, only when we say less than, we subtract. Sometimes the order feels odd to our student, but again, if x is 5 and I ask your student, what number is 2 less than 5, they would tell me 3. And the math sentence they would have to write is 5 minus 2, not 2 minus 5, right? If you say 2 less than a number, you start with that number and you go smaller than that number by 2. So x minus 2 is what we're looking for there. Letter C, 4 times x is most often written simply 4x. If your student wrote 4 times x, or 4 parentheses x, that's okay. Generally in algebra we just leave it as 4x and it's understood that that's a multiplication problem. Letter D, 1/5 of x. What we mean by that is take the number x, divide it into 5 parts, and count one of them. It's the same thing as x over 5. And actually, I wrote it like this. This is actually another way to write the answer. When you say 1/5 of x, it is perfectly fine. My kids could tell you this in their sleep because we said it so many times. The word of in math almost every time means a multiplication problem. So 1/5 of x means 1/5 times x. Again, you could put a times, you could put parentheses. Generally we do neither. We just say 1/5 x, or another way to write it is to say x over 5. Remember, 1/5 x, when we've done that in past years, if you have x and you divide it into 5 equal parts and you count one of them, that is x divided by 5. It's one of them, right? 1x over 5, or simply x over 5, or the same thing as 1/5 x. Our students need to be able to look at that and say all of those mean the same thing. So when the book writes it one way, they can, and it's more convenient to use it another way, they can transfer it to the other method, no problem. Number 2 tells us the product of two numbers is 10. First thing we need to know, math word, product. Product is always the answer to a multiplication problem. So when it says the product, you just need to know that you're doing a multiplication problem. The product is 10. Something times another something is equal to 10. One of the numbers is p. How would you write down an expression to find the other number? if that seems to cause your child to struggle, make it very practical. 2 times 5 is 10. So if I only knew one of those, how could I find this one? Well, 10 divided by 2, we undo multiplication with division. 10 divided by 2 is that number, and that number is 5. It doesn't matter which one you do, of course, because 10 divided by 5 is also 2. If you're missing one number, you can find the other by division. You undo the multiplication using division. So if p times something is 10, then it says we're trying to find an expression for the other number, so we have to give it a letter. It didn't tell us what the other number was. I'm going to call it N for number. That other number is going to be 10 divided by P. And of course it's true, yes it's true, that P is 10 divided by N, but remember it wants an expression for the other number, and so the other number is 10 divided by P. Number 3, write down an expression for the number of days in A weeks. A is the number of weeks. So if I have weeks and days, if I have 1 week, I have 7 days. If I have 2 weeks, I have 14 days. If I have 3 weeks, I have 21 days. What would my expression be for A weeks? Well, however many weeks you have, if you take 7 and multiply it by the number of weeks, you will have the number of days. So there are 7A days in A weeks. Okay, it feels a little abstract, but as concrete as you can make it to help your student understand, this number is 1 times 7. This number is 2 times 7. This number is 3 times 7, so this number is A times 7. We generally write that as 7A. Number 4. This one tells us that X apples were shared among Y children and none were left over. We're supposed to write down an expression for the number of apples each child received. Again, if that is too much for them, then let them think about 6 apples shared by 2 children, right? How many apples did each child receive? Well, this apple went to this child, this apple went to this child, this apple went to that child, this one to this child, this apple went over here, this apple went back over here. So each child received 3 apples, 6 apples shared by 2 children. I get to going too fast and write horribly, which is why I hope the parents are watching this more than the children. 6 are shared by 2, so each child gets 3 apples. How do we do that? Because we took the 6 apples and we divided it by the 2 children. Now guess what I'm going to do when I'm actually solving the problem? I have X apples and I have Y children. I don't know what that number is, but it's an expression. The number of apples each child will receive will be X over Y. That's how many apples each child will receive. And by the way, it is good to have your student write the word apples after the X over Y. X over Y is an expression. It will represent a number if you know the number of apples, the number of children, but your answer is that many apples, and you can even say that many apples per child if you wanted to have units with your answers. Number 5, part A, write an expression for P minutes in hours. Part B, Q days in weeks. That sounds a little bit abstract, like, okay, what are we supposed to be writing, right? Again, I would encourage you to take it very concrete. If I have 60 minutes, how many hours is that? well, that's 1 hour. If I have 30 minutes, this is P, right? If I have 30 minutes, how much is that? That's a half of an hour. Why is it a half of an hour? Because 30 minutes over 60 minutes is 1 over 2, and that's how many hours it is, right? We've changed it to hours by putting it over 60. If I have 15 minutes, right, it's a quarter hour. Now, we've done ratios in 5th grade, primary 5, and so we could even talk about it this way. We have 15 minutes. I'm going to multiply 15 minutes by 1 in the shape of an hour. 1 hour is 60 minutes. And when we multiply by 1, this fraction is equal to 1. And when I do this, the units cancel just like numbers, and 15 and 60 will cancel because 60 is 15 times 4, and that gives me 1/4 of an hour. So each time what we can see is that we're taking the number that we're given, and I didn't even write it here, but it's because it's 1 because it's 60 out of 60 minutes. Right? So the 60 goes on top. 30 minutes is 30 over 60 or a half. 15 minutes is 15 over 60 or a fourth of an hour. So P minutes is going to be simply P over 60. And that's how much of an hour P minutes is. Every time I want to change how many minutes it is to how many hours it is, I just put the number over 60. Some of this is not so much the math as thinking through how come 30 minutes is half an hour? Well, it's because the part is 30 over the whole is 60, right? If you want to make it more mathy, you could write a ratio like this, and that's okay. Nothing wrong with it. Q days in how many weeks? If you want to change the number of days to the number of weeks, right? 7 days becomes 1 week. 2 days, 14 days, sorry, becomes 2 weeks. How do you make 7 into 1 and 14 into 2? Well, you take the number of days and divide it by 7. That's 1. Take the number of days and divide it by 7. That's 2, right? And so if you have Q days and divide it by 7, that's how many weeks Q days is. Now notice I didn't do 3 days. We don't usually talk about a fraction of a week, 3/7, right? But all of these, if I pick numbers that I can wrap my head around and think, I can talk about 21 days into a number of weeks, how did I do that? Every time I divide by 7. Number 6, the length of a rectangle is A centimeters. And the width is B centimeters. Write down the expression for the perimeter. The perimeter is the length plus the width plus the length plus the width. And my units is centimeters. I only put in parentheses because all of this added together, that's how many centimeters it is. Remember the perimeter, if I start here, I go A and B and A and B. And so that's a fine way to write it. We could combine that like we did in the workbook and get 2A plus 2B. Another really great way that Singapore Math likes to help us think about perimeter is to think of it as this much, a length and a width, doubled. Let's use this bright blue, right? The dark gray and this blue color are the same thing, and so I could write it that way by saying it's 2 of those. Any of these is correct. All of them are true. I think it would be a decent thing to say that this is not quite simplified, but I think that this answer or this answer, either one is going to be good. I have a slight preference for this answer because of how many times we use the perimeter equation in that format, but it's not a deal either way. Do it however you would like to. Part B, we want an expression of the area. Area is always length times width. Remember, units. In this case, it's square centimeters. Part C, oh, no, there's not part C. It just says simplify your answer. And so AB square centimeters, and either of these wouldn't be an equal sign. You could possibly do that. All that does is help you realize that it's all of that centimeters, not just 2B centimeters. The 2A added to the 2B, that's how many centimeters it is. Not a big deal with the parentheses. It's not a mathematical thing as much as just a how to write it. Number 7. A bag contains U coins, V are removed, and W are added. How many coins will there be in the bag at the end? Well, you know, if you think about a bag, and inside are U coins, and you're going to take out V, and you're going to put in W, you can see that that would be U, take away V, add W, and this would be a great extension. You could just do U plus W, subtract V, and that would give you the same answer. How do you know? Start with things you know. This is 10, take out 2, put in 5. If you do 10 minus 2 plus 5 and have 8, and 5 is 13, that's good. If you say, well, I have 10, I put 5 in, and then I take away 2, that's 15 minus 2 is 13. That's a good answer. You could even say, I start with 10, and if I take out 2 and put 3 in, let me just write it up here actually. If I take out 2 and put 3 in, that's the same thing as just adding 3. That's 13. Look, we've done it 3 totally different ways. This is the same thing as 8 plus 5, 15 take away 2, or 10 plus 3. So however you write that, really there's only 2 ways to write it. U minus V plus W or U plus W minus V. Either of those is the same, and a little extension where you show them using concrete numbers how many different ways you can write that would be good. Number 8, we're supposed to find the value of the expression 8x minus 25 is equal to 0. The goal here is to solve this problem more with logic than with the algebra skills. What we want to understand is if I have a number and I subtract 25 and get 0, that number has to be 25. If 8x take away 25 is 0, then 8x has to be 25. There's nothing else it could be, right? And if I have 8 somethings, and it's the same thing as 25, if I want to know what one of them is, then I have to divide this into 8 groups, right? Take my 8x's and divide them into 8 groups, and that's 1x. So take the 25 and divide it into 8 groups, and that's what 1x equals. X is 25 over 8. Now we've done fractions. It was last year. But do you remember, this is 3 wholes and 1 extra piece. Okay, think about you have pizza cut into 8ths and you have 25 pieces. So there's 8 here, 16, 24. You have 1 more of these. You have 3 whole pizzas and 1 piece in that 4th pizza when you have 25 eighths. So the number x is 3 1/8. Number 9. A van can travel P miles on Q gallons. How many gallons of gas will it need to travel R miles? According to this problem, a van can travel P miles on Q gallons of gas. And we want to know how many gallons it will need to travel R miles. So the idea with this problem is to understand the terminology of cars. You have P over Q is the miles per gallon. that the car will go. And we generally, when we're talking about cars, we talk about how many miles per gallon it goes. But notice what this wants to know. It doesn't want to know how many miles for each gallon. It wants to know how many gallons you need to go a certain distance. So we're just going to do it the other way. We're going to say instead there are Q over P gallons per mile. Every mile you go, you have to go this many gallons. You have to use this many gallons, right? And so if I'm going every mile, I do this many gallons. Then if I go R miles, I have to do a multiplication problem and find that. And so it ends up that RQ over P is the correct answer. Now, when I'm looking in the back of the book, it throws a 7 in there. That's a misprint, has nothing to do with anything. It is simply QR or RQ over P, and the idea is to help our kids to think, you know, I can do miles per gallon. We often talk about that when we talk about car, fuel efficiency, all of that. But I can flip it over, and that gives me how many gallons I use for every mile. So if I multiply that times the number of miles, then I'm going to find out that I go RQ over P miles, or gallons of gas. That's how much gallons of gas I use when I go that far. Again, you could take that and make some concrete numbers, pick out some numbers in a sense out of the air. So for example, if you pick that you have 20 miles uses 5 gallons, which is horrible gas mileage, but let's pick easy numbers that we can work with, and you want to know how many gallons you use if you go 60 miles, what we have just done is said that I use 5 gallons to go 20 miles. That's 1 gallon for every 4 miles, and if I multiply that by 60, that's 15 gallons. And if you think about that, it makes all the sense, right? If I use 1 gallon every 4 miles, then in 60 miles I'm going to use 15 gallons. So we just tried our equation and it worked. And actually I did it as a two-step to exactly follow the equation. We would make it 5 times 60 over 20. That 60 look right there, you go. And that would give you the 15 gallons in 60 miles. So if it helps your student to be more concrete, do so. That feels like a pretty abstract problem to me. Maybe one you have to think about for a while with your student. Number 10, write an expression for an unknown length m and n in the rectangle below. Basically what this is asking us, since I know that these two sides are the same, and I could take that top side, if it's 3b plus 1, what we mean is it's b and b and b and 1, and I know it's the same as the opposite side, which is b and n. So what I know is this part is the same as this part, because b and b are the same. So the value of n would be 2b plus 1. And we do want to keep it this, we're going for the understanding of what we mean, okay? Yes, in algebra we're going to talk about 3b plus 1 is equal to b plus n. We're going to subtract b from both sides to come up with 2b plus 1 equals n. And I didn't say anything about this and canceling it out. All of that is true. But look at what we're doing. We're keeping it very concrete. We're understanding what it means at this level. We want to understand what it means to solve for n and recognize that n is the same part as this part of the graph. It's the same thing as 2b plus 1, and of course I really should say 2b plus 1 inches. Same thing on the other one. I have 4a plus 3 is the same thing as 2a plus 1 plus m. So let's find that. There's a, 2, 3, 4 a's, and 3 1s. And that's the same thing as 2 A's, a 1, and the rest of it is M. So 2 A's and a 1, 2 A's and a 1, whatever we have left is equal to M. Well, there's another A and another A and 2 more 1s. So from that, I can tell you that M is equal to 2A and 2 inches. 2A plus 2 inches is the value for M. It's much more about looking at the picture and understanding the picture than it is working on algorithms at this point, not the step-by-steps. Number 11. This question wants to know the largest possible value of A plus B plus C over D times E times F if A, B, C, D, E, F are different whole numbers from 1 to 9. If we want a large value, right, a large fraction is like 100 over 2. That's 50. If you have 2 over 100, that's less than 1. That's tiny, right? So what you're trying to do is get a large number over a small number. That's the first thing you have to understand. That's a logic step. I want the biggest number I could possibly get over the smallest number I could possibly have. The biggest number I can have, if I'm adding numbers together, and I'm using the digits 1 through 9, is 9 plus 8 plus 7. I can't get any bigger than that. The smallest number I can possibly have on bottom, I'm multiplying, is 1 times 2 times 3. That's the smallest I could possibly be. And so when you solve this, of course, 9 plus 8 plus 7 is 24. 1 times 2 times 3 is 6. The biggest number I could possibly have is the number 4. All right, the last problem in this section, number 12, has a diagram. We have a triangle with angles A, B, and 36 degrees, and we're given the fact that B is equal to 3A, and we're trying to find the values of A and B. There's a couple of things you have to remember here. One is that A and B and 36 are going to equal 180. We know that because any triangle always has that case. The three angles in a triangle, no matter what the triangle is, the three angles always are going to add up to be 180 degrees. That's just a fact that you have to know. Pull from your remembering of last year, and you can have that. Now, if this part added to 36 is 180, what is that number? If this is 180 and this is 36, what is that number? Well, we could find that by taking 180 minus 36, which would be the same thing as taking 180, take away 40, and put 4 back. And so that would be 144. I now know that A and B are 144. Well, that's good, but I'm not there yet. Here's the next thing you have to be able to pull up in your toolbox and use. B has a nickname. Now, I've told this story before in the class recording, I believe, but we could be at my house. You could come to my house, and your child could say, "Mrs. Barnett, may I have a drink of water?" And you could say, "Oh, Brenda, I like your carpet," and my child could come and say, "Mom, can I go to my friend's house?" And in the course of 30 seconds, I have had 3 people call me 3 different names, and nobody falls out of their chair. Everybody understands that some people are going to call me Brenda, some people are going to call me Mrs. Barnett, some people are going to call me Mom. And so in this case, same thing. Sometimes we call B 3A. So I'm going to do that because it's convenient for me to do that. If A plus B is 144, then A plus 3A is 144, and that's a great nickname because now I can say, wait a minute, I have, don't forget this means 1A, I have 1A and 3A, altogether I have 4 A's, and that's equal to 144. Now if 4 A's is 144, then one of them would be what happens when I take 144 and I divide it by 4. I like to think mental math anytime possible, and this is one of those times it's possible. 144 is 120 and 24. Write it down if you have to. You don't necessarily have to. This gives me the fact that A is equal to 36. 4 goes into 120, or 4 goes into 12 tens 30 times. 4 goes into 24 6 times, so A is 36. The question says find the values of A and B. I know that B is 3A. That's 3 times 36. 3 30s is 180. 3 sixes is 18. That means that, I'm sorry, 3 30s, I'm getting ahead of myself. 3 30s is 90. It's not 180. 3 30s is 90. Hold on, can't write and talk. 90 plus 18 is 108. So angle A is 36 degrees. Angle B is 108 degrees. And just because I'm a math teacher, it occurs to me that we really ought to try and make sure that we didn't make a mistake by adding all of these together. I have 100. I have 6 tens. And when I combine these, I'm going to get another 10. And that'll leave me with 2 extra. And I can use those with that other one to make another 10. So altogether, sure enough, I have 8 tens and nothing left over. And that is a good check. It makes sure that for this value of A and this value of B, that my angles in my triangle all add up to 180 degrees. All right, so that is the end of the assignment for the first week in word problems. And so that's the end of this recording. Thank you very much.